All right, we'll be continuing in section 5.2 today, working on some addition rules, some more probability rules, basically, and then talking about the difference between the word and the word or when we're dealing with probability. All right, so this reads multiplication rules. I like the word probability rules instead, but it's up to you if you want to change that. All right, let's go ahead and take a look here. These Venn diagrams, and we'll take you through an application that will show you the difference. All right, if we have the events A and B, they both have to be occurring. Okay, so it's kind of the overlap of those events, the shaded area here. But if it's one or the other, then all of these events would be shaded. Okay, let me take you through an example here using these deck of cards. Okay. All right, so we have event A, red cards from a deck of cards. B is going to be the queens from a deck of playing cards. Create a Venn diagram for cards that are red and queens. Okay, so let's start with that one. So let's create a box. Okay, so here we're going to do red and queen. All right, we only have two of those, right? Red and queens would be, let's see, we got the queen of diamonds, and then we're going to have the queen of hearts. Those are our two red queens. So how would we demonstrate that with a Venn diagram? Okay, well, event A is going to be the red cards. There is overlap for these two scenarios, right? Because we just talked about that. These two right here. So you want to just start with some circles that have some overlap for these events. I'm going to call this one to the left event A, and this one event B. Okay, and then the numbers you want to match up. In a deck of cards, there's 52 cards. Half are black, half are red. So event A has to be 26 red cards. Now, I don't want to put 26 here, and this is why. All of the circle needs to add up to 26. So what I really need is 24 here, and I need 2 here. Does that make sense? Okay, I still have 26 in the A circle. Okay, but 24 that are not red queens. I have 24 other reds and 2, though, that fit A and B. So for B, that event is the queens. Well, I have 4 queens. Okay, so this needs to be 2 and then 2 more here. All right, early on, some students will put too many. They'll put 4 here, but then once you go through it once, you understand there's not supposed to be 6. There's got to be the 2 plus the 2, the 4. Okay? All right, so what about red or queen? How's that going to look different? And you can shade this area in if you want. So, for this event, we'd shade that in, that 2, right? Matches up with what we had up there. Okay, but I wanted to show you an application with some words so that you can put some meaning to it. Okay? All right, let's go on to the other one. Now we have red or queen. So let's kind of start with the same setting. You know what, I forgot one thing here on this. Usually outside here, you put things that are not red and queens. Okay? So basically there's 52 cards, right? So we have 24, we have 28 accounted for. So that means there's 24 cards left over. So we put 24 somewhere outside of those. It's still kind of in the sample space of a deck of cards. All right? So if it's not red and not a queen, we have 24 cards left over, what that means. Okay? All right, so back to red or queen. These numbers are still set up the same, right? We have 24, 2 that are red and queen, and then we have 2 that are just queens, but they're not red because they're the black queens. Okay, and we still have 24 outside. All right, but red or queen, now the total for that is all of these, right? Red or queen, it would be all 28 of those events. All right, so red or queen would say there's actually 28 total that satisfy that. Red and queen, we only had 2 total. I didn't write 2, but we had the 2 events right there, right? Okay. So those words matter. Pay attention to it. Okay, so for the guided exercise, they want you to read through it and determine would it be appropriate to use the word and, okay, where it's like an overlap of the events, or would it be appropriate to use or, where you want to combine or add the events together. So read through them and just simply write down the word and or on the guided exercise 6. Okay, pause and do that now. All right, sometimes they come right out and use the word. Should be pretty obvious, right? We'd use the word or for this, one or the other. So we'd add those numbers together if we were finding the probability, which we will on the next page. All right, next one, buying new tires and aligning the tires. So we'd use the word and. Getting an A not only in psychology, but also, the word also is going to also mean and, right? It's got to be both. Okay. Having at least one of these, so it means whether you have a cat or a dog or a bird or a rabbit when it says at least one. Okay, so we're one or the other. So or would be appropriate there. Okay. All right, so let's go ahead and do the math for these ands or ors. We did the ands actually the first day. When we multiply events, that's when we see the word and. Okay. All right, so let's go ahead and take a look at this setting. Read this, take a look at the table, and then I'll walk you through A and B. All right, a lot of these tables usually totaled up for us. They kind of did tally marks. Kind of awkward, but here, why don't we write in some of these numbers here? Here they have the female row going across. So we have 9, and we have 3, 4, and 1. Okay, it's kind of the breakdown of numbers there. The males, we have 6 here, 5, 2, and 1. And a lot of times the tables are like that. They'll just give you the counts. For whatever reason, they decide to give you those tally marks. Okay, here they put some totals for us down here. So they totaled the freshmen, so the 9 plus the 6 is the 15, right? Okay, that all makes sense. These numbers are making sense. And usually at the bottom right, they also put the total of all of these. If we add them up, then what they told us there was 31, but that matches as well. Okay, could also make a total column over here to total the genders. So we had 14 here. Yep. So this is 14, and then this must have been 17 to get to the 31. Okay. All right, so here we go. Let's take a look at part A. Suppose we select one student at random from this class. Find the probability that the student is either a freshman or a sophomore. Now, when we see the word and, that was like drawing a queen and then a king, right? And then we had to multiply those events. That was last Thursday and Friday. Okay, but or here's how we're going to approach this. Let's write this down. Probability, use the probability notation of a freshman or sophomore. Well, what's the probability of the person being a freshman? Let's take a look at our table here. It's 15 out of the 31. Okay, that was section 5.1. They might ask you a question like that, just a simple event. What's the probability of a freshman? But it also said or sophomore, so we have to include both of these events. There's 8 sophomores. Okay, so the words matter, all right? Because now 15 plus the 8, I have 23 people that satisfy that condition of a freshman or sophomore. So I add those numerators together to get to the 23 over the 31. That's the probability. Okay? These are actually called mutually exclusive events. I'm getting ahead of myself a little bit, but I might as well start using it. Can I randomly select somebody from this group and select a freshman and sophomore at the same time? No, we can't, right? So if that's the case, there's no like overlap, then we say they're mutually exclusive. Okay? All right, let's take a look at part B. Select one student at random from the class. What's the probability that the student is either a male or a sophomore? Okay. So probability of male or sophomore. These ones are not mutually exclusive. Let me piggyback on what I just talked about, and we're going to have to account for this. I can randomly select somebody that is male and a sophomore at the same time. Okay, so we call these events not mutually exclusive. Okay, so here's what we're going to do. What's the probability of a male or a sophomore? Let's add them together. So male was 14 out of 31. Plus, what's the probability of a sophomore? That's going to be 8 out of 31. Okay, now look at the problem, though, with what we just did. Let's write those numbers down, and then let's take a look at the table again. All right, so the males, 14, and then the sophomores. These 5 kids right here were counted in both totals, right? Think about it. And sophomores, out of that 8, the 5 were included. And then when I include the total of 14 this way, these kids were included again. So we double counted these kids because, you can be male and sophomore at the same time. So we have to take one of those sets out. Okay, so since I double counted the 5 out of the 31, I have to subtract 5 out of 31. Okay, so by doing that, I end up with 22 minus the 5, and I get 17 out of 31. Okay, now there's a formula to help us with this. It's on the next page. Let me show you. When they are the general addition rule, if they're mutually exclusive, like freshman or sophomore, we didn't have to worry about it. It's simple. Add them together. But if they are not mutually exclusive, we have to subtract what I like to call the overlap, right? Or the part that was double counted. So we have the probability of A plus the probability of B minus the probability of A and B. So let's go ahead and go back and kind of do that underneath here so that you kind of get used to that. So when you realize that they are not mutually exclusive, we simply have to do this. Probability of male, that's event A, plus the probability of sophomore, and then we'll subtract the probability of male and sophomore. Okay, that'll be our general rule that we will apply in this situation when they're not mutually exclusive. Okay? A, they were, so we didn't have to. Okay, we could, but it would have been 0 out of 31. Because what's the probability of being a freshman or sophomore? Nothing. So we'd be subtracting 0 out of 31. So technically, I could use that rule for all of them, but you don't have to. Okay? All right, another phrase for mutually exclusive is disjoint. Okay, so when you see that, put those two together. And when they are disjoint, the probability of A and B is 0. Like the probability of getting a freshman and a sophomore when we're selecting the kid at the same time was 0. That would be the case when they're mutually exclusive. Okay, if it's something other than 0, like male and sophomore, then we'd say it's just not mutually exclusive. Okay, and there's the rules we just kind of worked on, and we'll continue to work on those. Okay, let's go ahead and look at the example on page 7. And then once we're done with that, let's have you guys try guided exercise 7. Okay, pause the video now to try that. Okay, so when you're going to have a couple problems in your OTI that are like this too. So what you want to do is go back a few pages to this dice sample space to figure it out. What's the probability of getting a 9? Well, here it is, the 3 and the 6, the 5 and the 4. Count those up. So that's how they're getting these probabilities. Okay? Obviously, you can't get a 9, 10, 11, 12 at the same time. They are mutually exclusive. We add up those events to get 10 out of 36 or 5/18. Okay? All right, go ahead and try that guided exercise 7. Okay, so yes, these are going to be mutually exclusive. You can't be loose and tight at the same time. Okay? And then if you're a little confused on which one to use early on, just use this one. This one will work every time because if they're mutually exclusive, this would be 0. Okay, so for part B, tight was 0.3, loose was 0.1, and that's enough since they're mutually exclusive, but if you use the other one, tight and loose, that probably would be 0 anyways. So we still get the same answer of 0.4. Okay, one more. Go ahead and turn the page and try guided exercise 8, and then we'll go over that. Okay, they're not mutually exclusive. Some students need work in both. All right, and then here's the general addition rule. We're going to need it. So probability needs help in math plus English minus the probability of math and English. So once we do that, obviously we're above 1 here, so we got to subtract that overlap. So we get 0.95 for the probability.